Hello, physics. I'm not here today. You should be in your assigned group watching this video and working along with your paper. It's not anything new. You know, we've learned everything there is to learn in Chapter 4. It's just new situations. Do your best. See you tomorrow. We're going to do some examples that I call Combined with Chapter 2 type. Remember Chapter 2? I know you don't have a book. But Chapter 2 was all the kinematics kind of stuff, the acceleration equations, the projectiles. And now we're doing Chapter 4, which is dynamics, the force problems. So what is the only quantity that we use that they have in common? Think about it. See what your group thinks. I hope you thought acceleration. The acceleration of the object. So that's the plan here. We will either use Chapter 4 stuff to find the acceleration of the object and then plug it in one of our Chapter 2 kind of equations, or we'll use the Chapter 2 equation to find acceleration to plug in the Chapter 4 force diagram equations. So it's nothing new, it's just combining them. Here we go. Everyone should have a paper and be following along and writing on their paper. What force is needed to accelerate a 40 kilogram object from 0 to 8 meters per second? Meters per second? You can tell that's Chapter 2 stuff. In 3 meters if the coefficient of friction is 0.344. We're going to play our game. We're going to do a regular thing. Underline, identify what you know, we'll make a force diagram, and then we'll make a plan and follow it. Pause the tape here, and you and your group discuss it and agree upon what each one of these numbers are. What force is needed to accelerate? So basically, what force do you have to push with? So this is the applied force. Kilograms measures mass. The speed's going from 0 to 8, so that's V initial, that's V final. 3 meters. Meters is the distance or displacement. And coefficient of friction, so that's mu. We'll draw a force diagram. Watch yourself on space here. I'm going to write pretty small. Don't make your diagram too big. This looks like the usual situation where somebody's pushing on something and causes it to accelerate. It's getting pushed across some surface that has friction. You and your group, quick, agree, and draw your force diagram and write equations. I hope your diagram looks like this. So in this problem, normal force equals weight, and the applied force minus the friction force is the net force. Let's make a plan. We'll be done with this problem when we find the applied force. The only equation that has applied force in it is the equation from the diagram. So we're looking for the applied force. Do we know the friction? No, we don't know the friction. We'll have to find the friction before we get to that equation. Remember, don't back up here yet until we're sure we're done here. We're looking for the applied force. To do that, we're going to have to know both of these. We're going to have to know the friction. We'll have to find that. We have to know the net force. We don't know that either, so we'll need that before this also. Okay, back to this part. We need to find the friction force. Well, we already used this equation. The only other equation that has FF in it is the friction equation. Let's see if we're ready for this. We're looking for friction. We need to know mu. Yep, we got it. And the normal force. We don't have the normal force. The normal force is the same as weight, but we don't have weight either. So we'll have to find, I'm going to say weight. We'll have to find weight. I'm going to write myself a note here so I remember that that is weight is equal to normal. I'm going to write find weight. Okay, so this equation will be ready when I get to it. Let's back up here. How am I going to find the net force? This is net force, but I already used it. The other way is F equals ma. Remember, that's one way I can use that equation. Net forces cause acceleration. So I'm looking for this net force. I do know the mass. It's up here. To do that, I'm going to have to know the acceleration of the object. Do I know the acceleration of the object? No. So somehow before I get here, I have to find the acceleration of the object. Okay, so this equation will be okay when I get to it. How am I going to find weight? That's easy. Weight, 9.8, F equals ma. So, am I going to be ready for this? I'm looking for weight, which is the F. I know the mass. Remember, that's the mass every time. And this will be 9.8, so I'll be ready for that. Acceleration of the object. How am I going to find the acceleration of the object? That's the chapter 2 stuff. That's where I'm going to make a list and pick an equation. So I'm looking for the acceleration. So, you and your group agree, make your list, pick an equation, find the acceleration of the object, and then follow your plan. Pause the video and don't start it again until you and your group have an answer. I said pause the video. Do it yourself. I hope you got this. Okay, I wrote this at school and I'm voicing it over at home. You can tell this V final here should have been an 8. I hope you got 563 newtons. Let's try another example. A 3 kilogram object is sliding 5 meters per second on a frictionless surface before it reaches an area with friction and comes to rest in 1.32 seconds. What is mil? So, something sliding along, maybe like on ice, and then it hits a spot that has friction. And that's where this problem starts. The problem starts when it hits the patch with friction. It was already going at constant speed, and object in motion stays in motion, straight line at a constant speed, so it was flying along at constant speed, and then it hit a spot that had friction, and then it slowed down until it stopped. We'll play our game, underline what we know, and identify it. Pause the tape and agree with your group on what these quantities are. Kilogram measures mass. When the problem started, it was going 5 meters per second, VI. When it ended, it was at rest. Seconds measures time. And you're looking for coefficient of friction. We need a diagram. Discuss it with your group and see if you can come up with your diagram yourself. Pause the tape. I hope you came up with this. Weight down, normal force up. And then just friction opposing its motion. I'm going to assume it was moving along to the right, so friction will be going to the left. That's it. So for this problem, normal force equals weight. And friction force is the net force. I hope that you got this. So make a list and pick an equation and find your acceleration. Pause the video now to do that, but then restart the video as soon as you found your acceleration. Okay, I hope you got this. When we go to plug this in the equation, though, for my net force, the acceleration of the object, we are not going to use the negative. The negative just means it gets slower and slower, or that means, that the acceleration basically was in that direction. It was moving this direction, but acceleration was that direction. But anyway, the negative is just the direction part. Do not include that. The way we set up our equations from our diagram kind of takes care of the direction part. Okay, so pause the video again and finish this out together as a group. So I hope you got 0.388. And remember, coefficient of friction does not have any unit. One more example. How far could you raise a 2.5 kilogram object in 3 seconds if the tension on the rope is 30 newtons? So you're accelerating this thing up. Because we're going to assume that it starts from rest. I probably should have said that. So pause the video right now. Go ahead and identify your numbers and also draw a force diagram before you start the video again. I hope you really stopped the video and did this yourself. So I'm looking for how far, that's a distance, kilograms measures mass, seconds measures time, and it says the tension is 30. And I said to assume it starts from rest, so you also know that V initial is 0. Every diagram has weight, and this one is a rope, accelerating upward, tension in the rope. And it's accelerating up, so tension has to be bigger. So tension minus weight is the net force. Okay, time to make a plan. We're looking for how far. We're looking for the distance, or the displacement. How are we going to get that? So this one, the last step of the problem, is going to be the chapter 2 stuff. Remember, anytime you have a velocity or a time or a distance, that's chapter 2 stuff. Make a list, pick an equation. We're looking for D. We know V initial. And we know time. But we need one more thing on our list. That's where the chapter 4 stuff comes in. We're going to use chapter 4 to find the acceleration of the object.